Pluto is a distant and confounding minor planet, once a part of our planetary group's family. However, current, alarming, and daring astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight with an astonishing revelation. They suggest the world is on a collision course with Neptune. Yet how could this happen, and what might be the consequences of such an event? Are we witnessing an intriguing cosmic eccentricity, or is there something more to this approaching limitless impact? Join us as we investigate the possibilities of a Pluto-Neptune collision. A planet once part of the official list, later downgraded to a dwarf planet, partly due to its odd orbit, remains a subject of interest and study in the grand astronomical community. According to recent predictions by leading experts, Pluto's path is dangerously close to Neptune's. Tyson and Kaku are raising the alarm about a possible catastrophic encounter between these two worlds, which they claim could pose a significant risk to Earth. How is such an event even possible? Pluto's journey around the Sun is unlike that of any other planet in our solar system. It takes an astonishing 248 years to complete one orbit, meaning that, since its discovery in 1930, Pluto hasn't even made one full revolution yet. But the intrigue doesn't stop there. Its orbit is highly elliptical, straying far from the nearly circular paths of the major planets. Even more remarkable is its 17 degrees inclination to the ecliptic plane, a much steeper path than other planets take. One of the most fascinating aspects of Pluto's orbit is its crossing point with Neptune's. For about 20 years in each orbit, Pluto is actually closer to the Sun than Neptune, defying what we might expect from their positions in the solar system. The answer lies in the gravitational effects of other planets. Shortly after Pluto's discovery, astronomers began studying its unusual path. Its steep inclination and elongated shape stood out, especially when scientists realized it crossed Neptune's orbit. The stability of Pluto's path, despite these peculiarities, is a testament to the intricate dance of celestial mechanics. This is where the three-body problem, the challenge of predicting how three objects, such as Pluto, Neptune, and the Sun, influence one another gravitationally, becomes relevant. Pluto's orbit is indeed chaotic, and tiny variations in its starting conditions could lead to vastly different outcomes over millions of years. Yet simulations show its orbit has remained stable over exceptionally long timescales, thanks in large part to the gravitational influence of giant planets like Jupiter, Saturn, and Neptune. Jupiter's immense pull, for example, helps keep Pluto on a relatively safe trajectory for potentially billions of years. Still, predicting events involving turbulent orbits like Pluto's is difficult. The inherent unpredictability of such systems means long-term forecasts are uncertain. While models can simulate likely paths, they also expose the limits of our predictive capabilities. So why are these prominent astrophysicists now raising concerns about a potential Pluto-Neptune collision? Tyson and Kaku argue that, despite stabilizing forces, the possibility, however small, exists for an eventual catastrophic encounter. Such an event would be both captivating and devastating for our solar system. Pluto, being smaller and icy, would likely shatter, scattering debris across space and potentially endangering other worlds. Neptune's atmosphere and orbit could also be altered, depending on the collision's energy. Kaku, a leading theoretical physicist and string theory proponent, adds that such an impact could create extreme conditions of energy and gravity that might allow scientists to test string theory predictions. For example, the collision could reveal new behaviors of fundamental particles and forces under intense conditions. Though Earth would be far from the danger zone, the scientific value of such an event could be immense. Studying Pluto's peculiar orbit not only deepens our understanding of celestial mechanics, but also provides practical insights for future deep space navigation, hazard prediction, and exploration. NASA's New Horizons mission, which flew past Pluto in 2015, gave us stunning views of its icy mountains, frozen nitrogen plains, and other exotic features, all of which help scientists piece together the story of this distant world. These discoveries have fueled interest in exploring more Kuiper Belt objects and refining our understanding of planetary classification itself. Ultimately, Pluto's orbit, with its eccentricity, inclination, and complex gravitational relationships, reminds us that the solar system is not a static place. It is a dynamic, evolving environment governed by both stability and chaos. The hypothetical Pluto-Neptune collision, however unlikely in the near future, highlights the delicate balance of forces shaping our cosmic neighborhood. As we continue to observe, model, and explore, Pluto's journey will remain a fascinating case study in the unpredictable beauty of the universe. The study of Pluto's orbit and its relationship with Neptune also feeds into broader questions about planetary migration and the early evolution of the solar system. Scientists believe that billions of years ago, giant planets like Jupiter and Neptune shifted positions, dramatically influencing the paths of smaller bodies like Pluto. This gravitational reshuffling may have caused the Kuiper belt to form as we see it today, with Pluto as one of its most famous residents. By examining how Pluto's path interacts with Neptune's over long timescales, astronomers can refine models of solar system formation. These insights may even help us understand how planetary systems form around other stars. The same gravitational principles apply universally, meaning Pluto and Neptune's delicate orbital balance could serve as a reference point for studying exoplanetary systems. In addition to its scientific importance, Pluto holds a special place in public imagination. Its reclassification in 2006 from planet to dwarf planet sparked heated debates among scientists, educators, and the general public. To many, Pluto remains the ninth planet, a beloved underdog in the solar system's lineup. Yet, as modern research continues to uncover its orbital quirks and dynamic history, Pluto is once again proving that it's far more than a frozen relic on the edge of space. If a collision with Neptune were ever to occur, the event would forever alter both worlds. The shock wave of such a crash could eject material into interstellar space, creating a debris field that might last millions of years. The resulting fragments could even form new moons or temporary rings around Neptune. These secondary effects would provide astronomers with an unparalleled opportunity to study the aftermath of a large-scale planetary collision, something rarely observed in real time. Kaku points out that, in the grand scale of cosmic events, such collisions are not as rare as we might think. The early solar system was shaped by violent impacts. Earth itself likely owes the formation of its moon to a collision with a Mars-sized body over 4 billion years ago. While a Pluto-Neptune impact is not predicted anytime soon, the mere possibility reminds us of the volatile nature of space. Looking ahead, missions to the Kuiper belt and beyond could help answer lingering mysteries about Pluto's orbit. These missions could deploy advanced probes equipped with high-precision instruments to map gravitational fields, analyze orbital resonance patterns, and monitor any shifts in trajectory over decades or centuries. Such data would not only clarify the stability of Pluto's orbit, but also provide a deeper understanding of the forces shaping the outer solar system. In many ways, the story of Pluto is a microcosm of astronomy itself, a field that thrives on curiosity, questions the obvious, and embraces the unexpected. Whether or not a Neptune collision ever occurs, the ongoing study of Pluto ensures that it will remain a scientific and cultural icon for generations to come.